Recording in progress.
Well, today we're going to talk about different types of probabilities: marginal, joint, conditional, different forms or different types of probabilities. This lesson introduces 3 types of probabilities that can be determined from two-way tables: marginal probability, joint probability, and conditional probability. Let us take a look at one example that we call two-way table, because it includes 2 variables, male and female. U.S. Census data. The United States Census Bureau collects large amounts of data about the population of the United States. So collecting data about everyone in the collection, which is our population. Remember that when you're gathering data about population, it takes a large amount of energy, time, money. You need a lot of people to collect the data correctly without any outliers. So collecting data about population is very hard, and it needs very exact instructions, including people, money, energy, and especially time. The two-way table below, so we have two-way table. It means that we are dealing with 2 variables. Contains 2010 census data showing marital status by sex for people over the age of 18 living in the United States. So note that numbers in this table are in millions of people. So when you see 32.4, it actually means it is 32,400,000 each. For each of these beans or hearts that you see, all of these are in million. Now, each of these numbers also rounded to the nearest 0.1 million, which is 100,000. Okay, let's take a look at this table here. We have some questions that we need to answer. So this is the status: male, female, and on the last column, we see the total. So each of these columns representing the variable. This is how they collected the data in 2010. This is the data that we have. It's just an example that we can use to see two-way table and answer some questions related to the probabilities that we're going to go over today: marginal probability, joint probability, and conditional probability. Well, okay. How many males never married? 33.7. How many females never married? 27.8. So remember that all of these need to convert it into million. And the total is 61.5. You might be interested in knowing how many males are married. 64.4 females, 65.1, and you have the total on the last column. Divorced And the next category, widowed. Okay. We also have the total on the very last row. The total of males, never married, married, divorced, widowed, which is given to us here, and the total of females who are never married, married, divorced, widowed are given to us here. And in sum, in total of all participants, so this number shows all participants, male or female with different marital status, which is given to us as 29.1. Okay. Question says, use the two-way table to answer the following questions. The very first one says, hey, what proportion of the adult population in the US is male? So let's take a look at this. What proportion of the adult population in the US is male? Well, okay, what is proportion? Remember that to find proportion, you're going to form a fraction. You have a numerator and you have a denominator. Note that when we are talking about proportion, we are somehow trying to define different types of probabilities depending on the type of question being asked. Well, okay. So how do we answer question 1? What proportion of adult population in the US is male? So we have different status for male. But in total, how many male do we have? This is equal to what goes on the numerator, the total of males in the United States who participated in this census is going to be on the numerator. 111.1 divided by, but out of how many? What is the total related to that question? Out of how many? So what is the total number of population who participated in this census? It is 229.1. What we usually do, we take this fraction. So this is a fraction. It has something on the numerator. It has something else on the denominator. We divide these two up and we round it. For rounding, we use this symbol, tilted equality, which represents approximation. And we write it as, after doing the calculation, is going to be approximately 0.485. We have a decimal number. We can convert this decimal number into percent. So 0.485 is 48.5%. We put the percent sign next to it. 48.5%. So it says, hey, what proportion of the adult population in the US is male? Your answer is, well, the proportion is about 48.5%. Let us move on to question 2. Question says, hey, what proportion of adult US population is currently married? Currently married. Well, okay. In this two-way table, the married one includes male and female. So I cannot just take males and say, hey, it's going to be 64.4, or just taking female, saying that, hey, I have 65.1 of females. It says, what proportion of the adult US population is currently married? Well, okay, currently married. It includes both male and female. Luckily for me, the sum is given here. 129.5. 129.5 divided by, again, remember that when you're talking about proportion, we have to have a number on the numerator, a number on the denominator. On our denominator, we need to find the total related to that question. It says, hey, the proportion of the adult US population who are currently married. So out of the total of the population, 129.5 divided by the total, which is 229.1. Again, when we have fraction like this, and we're looking for the proportion and eventually related these into probability, one of these is the answer to these probabilities. We're going to round this to a nice decimal number. Well, okay, let us do the calculation. Let's divide these two up. It's going to be approximately, it's going to be about 0.565, which is 56.5%. So your answer is, hey, about 56.5% of adult US population is currently married. Let us move on to the next stage. You need to know, we calculated the previous two proportions using only numbers in the margins or edges of the two-way table. Okay, let's read it one more time. We calculated the previous two proportions using only numbers in the margins or edges of the two-way table. These probabilities or these proportions are called marginal proportions or marginal probabilities. They have the same name, or marginal probabilities. Well, question 3 says, hey, the data indicates that 56.5% of adults in the US are married. Okay, where did it come from? It came from our calculation in question 2. Here we go. The proportion of adult US population currently married, calculated at 56.5%. If we choose just one adult at random from the US population, how do you answer this question? What is the probability that this adult is married? Well, to answer this question, since it says, hey, what is the probability? We're going to say, hey, there is a 56.5% chance that this randomly selected person is married. So we are selecting one adult at random. One adult at random. The probability that that person is married is 56.5%. There is a 56.5% chance that this randomly selected person is married. The probability that a randomly selected adult in the US is married is equal to the proportion. Probability is equal to the proportion of adults in the US who are married. This probability is an example of marginal probability. Why is that? Remember, when we calculated this probability, we only used the margin or edges of the table. Marginal probabilities are calculated using only the totals in the margins of a two-way table. A common practice is to use P to represent the probability. So note that we are moving on from proportion to probability. So we are interested in using a new terminology, a new symbol, a new method or way of representing that probability. So the probability that a randomly selected adult in the US is married can be written as P parentheses married. Probability of being married. P of married, probability that a randomly selected adult is married. This way of writing the probability is called the probability notation. So we represented proportion as a fraction. Now we are moving on to probability notation. There is no difference between probability and proportion. To calculate probability, we need a fraction. Let us answer question 4 and 5. Use the two-way table to find the following marginal probabilities. Well, question 4 says, hey, if we choose one adult in the US at random, find the probability that one person is widowed. The probability that that one person is widowed. Remember that probability and proportion, they have the same meaning. We have to have a fraction, something on the numerator, something on the denominator. What do we need? we need our table. So again, note that the probability of widowed. Let's take a look at our table. Widowed, okay. Take a look at this row, including information about male widowed and female widowed. What is their sum? Sum is 14.4. This goes on our numerator, 14.4. Well, what is on the denominator? It says in the population, you're randomly selecting an adult from the population. How many members do we have in our population? 229.1. This number goes on our denominator, 229.1. As usual, you're interested in representing this fraction in decimal form and finally in percentage form. Well, okay, let us just approximate this number. It's going to be 0.063 or 6.3%. What's the meaning of that? It means that there is a 6.3% chance that a randomly selected person is widowed. You can interpret it this way. There is a 6.3% chance of being widowed. Question 5 says, hey, if we choose one adult in the US at random, find the probability that that person is female. The probability, parentheses, female, it means that what is the probability that we randomly select a person from the population and that person is a female. We have probability, it means that we need to form a fraction. Probability and proportion, they are both connected together. So again, we need a fraction, a number on the numerator and a number on the denominator. By now, you should be guessing that, hey, the number on the denominator must be the same as the total that we used for previous question, because it says, hey, you are randomly selecting one adult from the population. The total number of people in the population is 229.1. But what goes on the numerator? How many females do we have? How many females do we have? The total number of females in our population is 118. 118 goes on the numerator. As usual, we are interested in finding the decimal and converting that decimal into percentage. Well, here we have 0.515 or 51.5%. Again, the interpretation is there is a 51.5% chance of being a female in this population. You need to know that the marginal probabilities involve only one of the categorical variables. Remember that when we're talking about categorical variables, they don't have any numbers like blood type, male, female. We often need to calculate probabilities that involve a combination of both categorical variables. Okay, combination of both of them. Since it's combination of both categorical variables, we call it a joint probability. A probability that focuses on a combination of two categorical variables is called joint probability. Let's take a look at a couple of examples to feel more comfortable about these calculations. So I'm going to put this table up here because we're going to use it. Question 6 says, what is the probability that a randomly selected adult is male and has never been married? So again, we have a randomly selected adult. We're interested in the probability that that randomly selected adult is male and has never been married. So we are joining two categories together. Two categories. So, well, based on definition of joint probability, we are dealing with a probability which is different from marginal probability. How do we calculate this number? How do we calculate this probability? First of all, note that we're going to write this probability as P of male and never married. So we're going to use the connector, the keyword and, to show that we are connecting these two categories together. Okay, first of all, it's probability. So definitely I have to have a fraction. What is my numerator? What number is on the numerator? I'm looking for males who are never married. Males, so this is the category for male people, never married, male and never married. So take a look at this. Male and never married is going to be this category here, 33.7. 33.7 goes on the numerator. What is on the denominator? I'm looking at the whole population. So what goes on the denominator is 229.1. So male and never married. You look at the male and never married, the intersection is going to be 33.7. They join together at this number, which is 33.7. Let us round this. The approximation is 0.147 or 14.7%. Next question. It says, well, if an adult in the US is chosen at random in the US population, is chosen at random, what is the probability that person is female and married? Female and married. Again, this connector here, this keyword here shows that we are dealing with a joint probability. Okay, let us move on to calculating this algebraically. We have a fraction. As you guessed, the number on the denominator is the same as the number of population, 229.1. On the numerator, however, we are looking at female category who are married. Female category who are married, which is 65.1. 65.1 of females who are married. 65.1. Well, okay. The approximation 0.284 or 28.4%. And finally, if an adult in the US is chosen at random in the US population, is chosen at random, find the probability that that person is male and divorced. The connector, the keyword, and we have a joint probability. It is equal to what goes on the numerator, what goes on the denominator. The denominator is going to be the same, 229.1, male and divorced. Male, so male and divorced. Male and divorced, just 10. Approximation gives us a 0.044 or 4.4%. There is 4.4% chance that when you randomly select a person from population is male and divorced. Next steps, marginal probabilities and joint probabilities show us the likelihood that a randomly selected adult in the US is in a particular category or in a combination of categories. These probabilities provide valuable information. However, they don't allow us to determine if there is a relationship between categories or not. So they do not connect different categories together. They say, hey, you have male and married, you have female and divorced. They don't see any relationship here between those categories. Well, As a statistician, you're interested in finding probabilities that related to relationships between those categories. We call it conditional probability. In this case, they do not help us figure out if there is a relation between, for example, sex and marital status. Suppose we want to know whether the likelihood that a person is widowed is related to his or her sex. So think about it. How do you connect a person being widowed to being female or male? We cannot use a joint probability or a marginal probability to answer this question. Instead, we're introducing a new probability, and we call it conditional probability. Okay, let's explore what conditional probability can tell us about the relationship between the sex of an adult in the US and the probability that he or she is widowed. The type of question that you're going to see related to conditional probability is going to be as follows. First of all, we will first find the probability that a randomly chosen adult is widowed. We are starting with the fact that the adult chosen is female. So this is the question that you want to answer. A person is widowed is related to his or her sex. We're using conditional probability, and these are the steps that you're going to take. So in question 9, we're going to answer this question, then we're going to go back to answer the previous question that was posed here. Remember that in part C, it says the proportion of female adult population of US is widowed. We're looking for that proportion. What's the difference between C and the format you are asking question using a joint probability or marginal probability? What proportion of the female adult population of the US is widowed? How do we answer this question? Are we going to use the whole population to answer this question? Or are we going to use just females to answer this question? It says, it doesn't say the whole population. It says what proportion of female adult population. So this guy is going to be on the denominator. This is not the whole population for you. It is just some part of the population. And then from that population, from that specific population, the ones who are widowed. Let's take a look at our table here. Our table says, well, okay. Confusion. Female adult population. This goes on the denominator. Female, 118. Widowed, female who are widowed. Female who are widowed, 11.4. So see the difference between the marginal probability and the conditional probability. For marginal probability, for joint probability, we're going to use the whole population as the denominator. But when it comes to conditional probability, we just focus on the category that we're dealing with. We're not dealing with the whole population. We're just dealing with the female category with total number of 118. That number goes on the denominator. What goes on the numerator? The proportion, the portion of female category who are widowed, which is 11.4. Well, okay, the rest is just calculation. This is 0.097 or 9.7%. Since proportion and probability are the same, the answer to part D is going to be 0.097 or 9.7%. We're using some part of the population, not all of it. So we're dealing with conditional probability. So if I ask you to answer this question, that a person is widowed is related to his or her sex, it means that we need to deal with different categories here, male or female. Perfect. So let us take a look at another example here. Question 10 says, well, now let's find the probability that a randomly selected male is a widower. A randomly selected male is widower. Okay. First of all, you should stop asking yourself, is this marginal? Is this joint? Or is this conditional? Okay, marginal, well, it's not actually marginal because it's not dealing with the whole population. It's just dealing with one category. So it cannot be marginal. Do we have keyword and? We don't see keyword and here. Male is a widower. The probability that randomly chosen male is a widower. We don't see keyword and, so it's not going to be joint. The only option is left is conditional. Well, okay. It doesn't matter if you're calculating the probability or proportion. They are the same thing. The proportion of the male adult population of the US who is widowed is going to be, well, we have a fraction. On the denominator of the fraction, instead of having the whole population, we're just using male population. But what is the male population? Take a look at your table. Table says, well, male population is going to be 111.1. So 111.1, this number goes on the denominator. 111.1. What is on the numerator? From that category, widowed is going to be just 3. From the male category, the widowed is going to be 3. So it is 3 divided by 11.1 approximately is 0.027 or 2.7%. And we know that probability and proportion are the same. So it's going to be 0.027 or 2.7%. We just copy down the number that we calculated in part C for part D. Proportion and probability are the same thing.